This part will be fun, as you will apply the Naïve-based classifier on real test examples. It is similar to what you did in the first video of the week, but we'll cover some special corner cases. Once you have trained your model, the next step is to test it. And you do so by taking the conditional probabilities you just derived, and you use them to predict the sentiment of new, unseen tweets. After that, you'll evaluate your model performance, and you'll do so just like how you did it in the last week. You use your test set of annotated tweets. With the calculations you've done already, you have a table with the lambda score for each unique word in your vocabulary. And with your estimation of the log prior, you can predict sentiment on a new tweet. This new tweet says, "I passed the NLP interview." You can use your model to predict if this is a positive or negative tweet. So before anything else, you must pre-process this text, removing the punctuation, stemming the words, and tokenizing to produce a vector of words like this one. Now, you look up each word from the vector in your log likelihood table. If the word is found, such as I, pass, the, and NLP, you sum over all the corresponding lambda terms. The values that don't show up in the table of lambdas, like interview, are considered neutral and don't contribute anything to the score. Your model can only give a score for words it's seen before. Now you add the log prior to account for the balance or imbalance of the classes in the dataset. So this score sums up to 0.48. Remember, if this score is bigger than 0, then this tweet has a positive sentiment. So yes, in your model and in real life, passing the NLP interview is a very positive thing. You just predicted the sentiment of a new tweet, and that's awesome. It's time to test the performance of your classifier on unseen data, just like you already did for a different scenario in the previous module. Let's quickly review that process. As applied to Naïve base, this week's assignment includes a validation set. This data was set aside during training and is composed of a set of raw tweets, so xval, and their corresponding sentiments, yval. You'll have to implement the accuracy function to measure the performance of your trained model, represented by the lambda table and the log prior, using these data. First, compute the score of each entry in xval, like you just did previously. Then, evaluate whether each score is greater than 0. This produces a vector populated with zeros and ones, indicating if the predicted sentiment is negative or positive, respectively, for each tweet in the validation set. With your new predictions vector, you can compute the accuracy of your model over the validation set. To do this part, you will compare your predictions against the true value for each observation from your validation data, yval. If the values are equal and your prediction is correct, you'll get a value of 1, and 0 if incorrect. Once you have compared the values of every prediction with the true labels of your validation set, you can compute the accuracy as the sum of this vector divided by the number of examples in the validation set, just like you did for the logistic regression. Okay, let's revisit everything you just did. To test the performance of your Naïve-based model, you use a validation set to allow you to predict the sentiment score for an unseen tweet using your newly trained model. Then, you compared your predictions with the true labels provided in the validation set to get the percentage of tweets that were correctly predicted by your label. Then, you compared your predictions with the true labels provided in the validation set, and this allowed you to get the percentage of tweets that were correctly predicted by your model. You also saw that words that don't appear in the lambda table are treated as neutral words. Now you know how to apply the Naïve-based method to test examples. In the coding exercise at the end of the week, you will use it to classify tweets. Next, I'll show you other things it can do.